Okay, so that was nomenclature. Now we're going to talk about something a bit different. Formula mass. So we've talked about atomic mass. Atomic mass is the mass of an atom. Formula mass is the mass of a molecule or a formula unit. If you looked at the formula for the compound, it's the mass of the formula. And all you do is you add up the masses of the atoms that are in the formula. So we can make it look really complicated by making it into a math thing here. It's just add up all the pieces. That's all it is. It's also sometimes called a molecular mass because it's the mass of a molecule or the molecular weight. Formula mass is a little more generic because it applies to ionic compounds as well as molecular compounds. So calculate the formula mass of calcium nitrate. And we're going to sneak some nomenclature practice into these problems. Because to calculate the formula mass, I need the formula, right? So we have to practice. So calcium nitrate, is calcium a metal? Yes. This is an ionic compound. So I'm going to have ions. I'm going to have calcium, and calcium's in group 2, so it has a +2 charge. And then I need the formula for nitrate ion, which I memorize. And then I look at the charges and I figure out how to put them together. And I see that I need 1 calcium and 2 nitrates. Because I have 2 of that bundle, polyatomic ion, I put parentheses around it, the shrink wrap, and I write on the outside how many there are. Okay, so that's review. Calculate the formula mass. So I'm going to look at the formula. There's 1 calcium. There are 2 nitrate units, but that's 2 nitrogens and 6 oxygens. Everybody see that? And so I'm going to find the mass of calcium atoms and nitrogen atoms and oxygen atoms, and I'm going to multiply by how many there are and add them up together. So there's 1 calcium, and I look up calcium, and it's 40.08 atomic mass units. And there are 2 nitrogens, and that's 14.01 atomic mass unit. And then 6 oxygens, 16 atomic mass units. It's really a good idea to write it out like this because it's easy to make mistakes, and it's easier to find those mistakes when you've written it out. So my calculator is giving me 164.1 atomic mass units. That's the mass of the formula unit. It's an ionic compound. It doesn't actually have molecules, but it's the mass of the formula unit. And then we could debate significant figures, right? These get a little icky because we have multiplying and we have adding, and so you can get into some arguments about which takes precedence or whatever. My feeling is when you calculate a formula mass, you're never going to get those ridiculous number of decimal places. Those things happen when you multiply and divide, mostly dividing, and here we're just multiplying by whole numbers and adding, and so we don't have that happen. So I think the easiest, the safest thing is just write down all the digits your calculator shows you. Occasionally we should add one, but it's usually not going to cause a problem. So you could argue that this one should have 4 sig figs, or you could argue that it should have 2 decimal places. So we could put a 0 there if it made us feel better. Any questions? When we use this in a calculation, it's usually going to be one of the other numbers that limits the number of significant figures. And again, when you're rounding these, I give you permission to round them down to 4 sig figs, 4 digits, but no further. So this is 16.00, don't round it to 16. I know that's not going to affect the calculation, but when you start getting rid of the 08 and stuff starts to get messed up. So 4 digits minimum. If you want to use all of the digits that are on whatever periodic table you're looking at, go for it. More digits are better. You can always knock them off later. 164.10. Okay, so molar mass of a compound. That is the mass of 1 mole of the compound. And so just like with atoms, where the molar mass was the same number as the atomic mass, we just changed the units, that's also the case for compounds. It's numerically equal to its formula unit, but the formula mass, it's numerically equal to the formula mass, but the unit is gram instead of atomic mass unit, because it's a mole of them. So what's the molar mass of ammonia? What's the formula for ammonia? NH3. Because I told you to memorize it. Excuse me. So NH3, I've got 1 times the molar mass of nitrogen. So this is 14.01 grams, right? And I've got 3 times the molar mass of hydrogen, 1.008 grams. So the calculator is going to say 17.034 grams. Is that an extra sig fig? Yeah. Does it really matter? No. It's not worth thinking about. So this is the mass of 1 mole of ammonia. So you can write it that way. Or you can say the molar mass is 17.034 grams per mole. Any questions? Just like what we did with elements, except now we're having to add some stuff together. So we can use the molar mass combined with Avogadro's number to count number of molecules in a given mass of compound, just like what we did with the atoms. So find the number of ibuprofen molecules in a tablet containing 200 milligrams of ibuprofen. These end up being dimensional analysis problems. Bless you. Bless you again. So we've got a number. Let's write it down. We've got 200 milligrams of ibuprofen. And what are they asking us to find? Number of molecules. Well, we've been doing things with grams, right? Could we convert milligrams to grams? Sure. And then to get from grams to molecules, what's going to be in the middle? Moles. Moles in the middle, like Malcolm in the middle, right? Moles in the middle. Always try moles in the middle. So there's moles. Grams to moles is the molar mass. Moles to molecules is Avogadro's number. Moles to atoms, moles to ions, moles to fish, moles to sandwiches, whatever. It's things, right? So if it's a molecule or an atom, it's still Avogadro's number. Like a dozen peanuts is the same number as a dozen donuts. It's 12 things. So there's my path. That's the hard part. Many people resist writing down the path. And then you struggle with the problem and it gets all messed up. Write down the path. Just humor me. Write it down. Because then you have something to go off of. This is like, okay, well, I need to go to this new place and my GPS on my phone's dead, and so I can't use that. I need to write down the directions. If you really want to get there, you're going to actually write the directions down so you can follow them. Because if you just have them in your head, you might forget, and then you get lost, right? This way you have it written down, and you can make sure that you're following it. So 200 milligrams. And I have 3 arrows. I've got 3 conversion factors. I'm going milligrams to grams, to moles, to molecules. It's tempting to start doing stuff with numbers at first. No, just get the units in there. And then the moles go down here, and the grams go down here, and the milligrams go down here. So the milligrams cancel, the grams cancel, the moles cancel, and I get the desired unit. This now tells me where to put the numbers. So over here, molecules and moles. Mole is like a dozen. So it's 1 dozen is 12 things. It's 1 mole is that funny number, Avogadro's number of things. You don't want to get it backwards, because it's silly to say that 1 egg is 12 dozen eggs, right? It's ridiculous. The molar mass, we're going to have to calculate that, so I don't feel like doing that right now. Let's do the other one first. Some of you are still a bit iffy with your metric prefixes. I know because I graded worksheet 1, and I saw some disturbing things. So worksheet 1 is graded, and you should pick it up and look at it. I spent a lot of time looking at everybody's things because I want you to learn from your mistakes. Okay? So down here I have milli, and up there I don't have milli. I need to know what milli stands for. Milli stands for times 10 to the minus 3. And that's something you just flat out memorize. So I put milli on the bottom and what it means on the top. I don't want to put them together because this milli is an abbreviation for that. I need the top to be equal to the bottom. So 1 times 10 to the minus 3 is the same as 1 milli. Okay? There are other ways that you can do that, but this is a pattern that you can always follow the pattern, and it always works. Okay, molar mass in the middle, I have to calculate that. They gave me the formula because there's no way we expect you to know what the chemical formula for ibuprofen is. 13 carbons times the mass of carbon, 18 hydrogens times the mass of hydrogen, and 2 oxygens times the mass of oxygen. Yes?
Why is 10 to the negative 3 on the top?
Because milli's on the bottom.
Oh, that would be the equation. That would be the equation.
Right. So, because I know that there are several people that are still just like, what are you doing with that? Okay, so let's think about it this way. If I have 1 gram over 1 gram, the top is equal to the bottom, right? Because in dimensional analysis, what I'm doing is I'm multiplying by a fraction that is equal to 1, so I'm not changing the value of the thing, I'm just changing the units. So 1 gram over 1 gram. And I could write 1 milligram over 1 milligram, right? And that's the same thing. Or I could take one of those millis and trade it for what it stands for times 10 to the minus 3. One milligram over 1 milligram. I could remove this one and change it to times 10 to the minus 3. But if I put milli and 10 to the minus 3 together on the same side of the line, then I've squared it, basically. I have times 10 to the minus 3 times 10 to the minus 3, and that is not equal to 1 milligram, or 1 gram, okay? So the prefix, the letter, and the number don't go together. Never put them together. So molar mass, 13 times 12.01 plus 18 times 1.008 plus 2 times 16 So my calculator says that. Not quite, this. I was thinking about the train. Is it too many digits? Yeah? Does it matter? No? 4 sig figs here, 4 sig figs in Avogadro's number. So if I've got extras there, it doesn't matter. This is not going to limit the number of significant figures, and so I'm just going to be okay with it. That's grams per mole for ibuprofen. So I look at where I've put the units here. It's this many grams is the mass of 1 mole. So this number goes in the bottom here with gram. 206.274 grams is the mass of 1 mole. So much less thinking when you do it this way. Okay, so 200 times 1 EE negative 3 divided by 206.274 times 6.022 EE 23 equals. Remember, the EE button is short for times 10 to that. So this should have 4 sig figs, 5.8. I'm going to cheat and do my rounding right now. Times 10 to the 20th molecules. There's no abbreviation for molecules. When you write down that 5.839, be sure to look all the way at the end of the number. On my calculator, there's an E20. Don't ignore that. That's times 10 to the 20. That's super important, right? Any questions? Yeah.
When you write the answer, do you want us to specify like molecules of whatever the...
That's a good question. Should we specify molecules of ibuprofen here? It never hurts. In this case, it doesn't matter. But when we get into ones where we're doing chemical reactions or where we're talking about how many carbons in the ibuprofen, then it does matter. Yeah, good question. Anybody else? There's the answer.